Thanks again for joining us for the Energy Smart Living with Heat Pumps webinar. We really appreciate you taking part, and we hope that you find it worthwhile and get some good information from it. Our plans today is we'll do a quick introduction of all the presenters. We'll talk about current and future rebates specific to the Marshall Fire rebates. We'll talk about heat pump rebate requirements for the Marshall Fire, the basics of how heat pumps work, cold climate heat pumps versus non-cold climate heat pumps, living with heat pumps. We'll give you a number of resources where you can find more information. And we're trying to get to the question and answer part as quickly as possible so that we can spend as much time as possible with Q&A. With that being said, there is a Q&A function in the Zoom. We hope that you utilize the Q&A function so that we can address some questions as we go, and we'll address a bunch of questions at the end of the presentation as well there. We're going to start off with a poll, and Zach is going to start the poll question. So take some time and answer the poll questions, and while you're doing that, I will do some introductions of our presenters here. So our first presenter is Zach Swank. He's the Deputy Director of Boulder County's Office of Sustainability, Climate Action, and Resiliency. Thanks for joining us, Zach. I'm Robbie Schwarz. I'm the New Homes Building Advisor for the Marshall Fire. That's me. Sean Lamons was formerly with Mitsubishi, but now is with Midwest HVAC and is a heat pump expert that is joining us today, as well as Eric Leaf, who is formerly with Now Heating and Air and is now with Lennox International. And then we have Stuart Cummings and Paul Bosquet. I'm not sure I pronounced that correct, Paul, but you can.
Close. Bousquet.
Bousquet, okay.
Yep.
With Go Electric Colorado, a nonprofit organization that is providing advisory services for electrification across Colorado. So we have a good suite of people to speak to your questions and help educate you on heat pumps tonight.
All right, so I think we have, we've got 48 of the 64 attendees have filled out the poll here. So 25% are homeowners who have lost a home in the Marshall Fire, and 67% are homeowners who did not lose the home in the Marshall Fire. We have a few architects with us and a few others in attendance as well. 83% of the folks on the call tonight live in Boulder County, and 18 or live or work in Boulder County, I should say, and 18% do not. For those who did lose a home in the Marshall Fire, we have 3% who have completed their new home and moved back in, 26% that have construction underway, 3% that have a permit filed, and 3% that are in the design phase. And then of those percentages, it also counts the 66% that did not lose a home in the Marshall Fire. So that's why that doesn't add up to 100.
Perfect. Well, thank you for that.
Yeah, thanks for answering that poll, everybody. It helps us understand how to tailor this presentation, and I think we've got a little something for everybody.
Yeah. So let's begin with incentive program requirements. So we see that especially the Xcel rebates for the Marshall Fire rebuild are based off of building programs. And the primary reason Xcel chose to do that is that there are well-defined requirements within these national building programs out there. They're associated with checklists that are easy to follow, to understand the requirements. And they're also based on sound building science for how to build an energy efficient home that meet our modern expectations of comfort, durability, efficiency, resiliency, and whatnot. The one kind of downside with using these national building programs is that Xcel had the expectation that the builder architect role would be to guide the homeowner through the building requirements and verification process. But a lot of the builders in the Marshall Fire specifically were custom builders who had not taken part in a national building program in the past. Therefore, that role has, to some extent, fallen on the homeowner. But the reality is that the homeowner should be relying on the builder architect to build the house, and the homeowner maybe's role really is potentially applying for the rebate and gathering some of the information that's needed to claim that rebate. Therefore, for those homeowners who are in the process of building the house that haven't pulled a permit yet for the house or created a contract with a builder, one thing to consider is potentially creating a contractual requirement that the house be verified and certified as an Energy Star version 3.2 / next gen electrified house, for example. That would be one kind of performance characteristic that you could add to your contractual relationship with your builder and architect. You could also add other types of requirements, like the house meets a certain air tightness, or that the house meets a certain level of performance based on the ResNet HERS Energy Rating Index score, or those types of things there. Next, we wanted to talk a little bit about your building your building team. This has kind of been something that we've been talking about since the beginning of our work with the Marshall Fire Rebuild. On the rebuildingbetter.org website, there's a great section that talks about how to build your team, choosing how to choose an architect, a builder, the relationship between the HERS rater or energy consultant that's needed to successfully build a house that performs and can meet some of these rebate criterias, and then the coordination with HVAC contractors. The big thing to think about with this team is that it takes a lot of teamwork and coordination to understand these programs and these new mechanical systems. So to properly design and specify the equipment that's needed, the insulation, the house tightness levels, all of those types of things, to select and install all of the requirements that are embedded in these national program requirements that are detailed out in the detailed checklist for the building thermal envelope, as well as the HVAC design in the house. And then a lot of times you'll need some level of verification and education about these program requirements. The HERS rater and the energy consultant are really part of that team to help verify that what's required by these programs and these incentive programs or rebate programs are actually installed and installed well, and to help educate the architect and builder for what is required to be installed in those houses. And then it all comes down to scheduling and executing and how the building process works out, and ensuring that everything is sequenced properly so that it's installed properly so that it will ultimately perform properly. Our ultimate goal and goal setting is also really important to understand. This team is building to the same goal, and they're working together as a coordinated unit to achieve that goal. And that goal might be just achieving these rebates categories. Now, the rebates for Xcel in the Marshall Fire arena have been pretty constant for quite some time. And we're not going to go over these in great detail, except that we really want to let people know that on July 1st, if you haven't permitted your house before July 1st, the rebates do change, and they change pretty significantly. You'll see here that the first 3 tiers of the rebate categories go away on July 1st. If you permitted your house after July 1st of 2024, you'll be looking at only being able to comply with the Energy Star 3.2 plus next gen electrification rebate or the passive house rebates. And this is due to a ruling by the Colorado Public Utilities Commission that says that starting July 1st, new homes with gas services are no longer eligible for gas Xcel Energy rebates if they're built with gas installed to those houses. It doesn't mean that you can't build a house with gas, but in order to get the rebates moving forward, you have to participate in one of these programs, which is getting you towards electrification of that house. I also wanted to do a quick overview of the state of Colorado electrification rebates. You'll notice that there are three categories in the electrification rebates. They're similar to the Xcel Energy rebates, but you do want to know that the qualifications are slightly different. They're only looking at the electrification portions and those pieces of the electrification puzzle that use substantial amounts of energy. So you'll see that you'll have to qualify with a qualified air source heat pump, for example, a cold climate heat pump, a heat pump water heater that qualifies with the requirements, and use an electric stove or an induction cooktop. That would qualify you for $10,000 if you were to do that, and that can be added on top of the Xcel rebates there. You'll see that you can do the same thing, but with a ground source heat pump, and that gets you an additional $10,000 for a total of a $20,000 rebate. Or you can install a ground source heat pump by itself and get a rebate of $10,000. There are also rebates that have come out for existing homes specifically, and here's some resources where you can go to find out more information about the rebates that have come out for existing homes in the electrification arena. So for heat pumps, for induction cooktops, for heat pump water heaters, and so forth and so on. You really want to look at your specific municipality and your utility to give you the information for what rebates are available for you in those if you're in an existing home that you're considering to upgrade that as well. So let's talk a little bit about heat pumps and how they work before we do a deeper dive there. Well, one of the things that we need to understand about heat pump technology is the basic building thermal envelope and the correlation between the building and the technology that we're going to be entering or installing into that house there. And the building science is telling us that we have to have a really sound, well-performing building thermal envelope that helps us gain control and predictability, and specifically control and predictability of airflow, moisture flow, and heat flow or thermal flow in our houses. And in order to do that, we need to build our houses tight. And because we're building our houses tight, we need to ventilate them correctly. So kind of the two building science principles that we want to kind of hammer home here is the idea of control and predictability and the idea of building tight and ventilating right for the house. And if we do that, we can meet our modern day expectations of comfort, efficiency, durability, and resiliency in that house there. So build our houses tight, have that great building thermal envelope, and our heat pumps will work. And when we talk about the heat pump specifically, we need to understand that the heat pump itself does not generate heat or energy in that house. Unlike a traditional gas furnace that's burning gas and generating heat, a heat pump actually moves energy or heat from one location to the other location. It transfers heat from inside the house to outside the house when you're cooling. It transfers heat from outside the house to inside the house when you're heating that house, when we're talking about air source heat pumps. And a great analogy here is some common heat pumps that we might interact with on a daily basis, like a refrigerator. A refrigerator cools itself using heat pump technology. A freezer on the bottom of that refrigerator creates that very cold environment by using heat pump technology, in the same way that our common air conditioners, our room air conditioners, or our traditional whole house air conditioners are using heat pump technology to cool the house there. So when we think about a freezer, for example, it's taking energy out of the space of the refrigerator and making that space cold enough to actually freeze that steak that we've stuck in that freezer, for example. So when we take that to a house in the summertime, it basically works exactly like our typical air conditioners. We're extracting energy or transferring energy from inside the house to outside the house to cool the house. So we're transferring that energy. We're not creating cold energy. We're transferring energy out to cool the house. And what's interesting about the air source heat pumps or ground source heat pumps is that they have what's called a reversing valve. So it takes that air conditioning and it reverses the flow of the refrigerant so that we're now taking energy from the cold air outside of our houses, and we're able to put that energy into the house to actually heat the house. So we have a system that can work in either heating mode or cooling mode, one system that can heat and cool our houses. So kind of a quick explanation of how heat pumps work, and we'll get into a little bit more detail with some of the other presenters there. Now, from the perspective of the Marshall Fire rebates, I wanted to talk real quick about what is the requirement for the heat pump that's being installed in a house that's getting an Xcel rebate or the rebate from the state of Colorado electrification. The first thing is that it needs to be a cold climate air source heat pump and an Energy Star certified heat pump, or a heat pump that meets the same qualifications as an Energy Star heat pump. And that means that it needs to be installed according to the Energy Star version 3.2 requirements, meaning that we have that sound building envelope, that we have HVAC design, and then we have some verification of those two things that have happened there. The unit has to have a capacity, which means that it has to have at least 70% capacity at 5 degrees. And that capacity will be talked about a little bit more, but that is one of the key requirements there. We'll talk about it a little bit more as we move forward here. It also has to have a variable capacity fan speed so that it can run low and slow at a variety of different fan speeds to deliver heat and cooling energy around the house. And then it has to have a certain efficiency in its cooling mode and its heating mode. And SEER is a measurement of its cooling mode efficiency, which is seasonal energy efficiency. And HSPF is heating season performance factor. That's a measurement of its heating season performance. And basically, the higher the numbers, the more efficient it is. And these are kind of the minimum numbers that would be qualifying for a Marshall Fire rebate there. Then we have certain groups out there like the Northeast Energy Efficiency Project that has put together certification lists. So we can look at the what's called the AHRI number, or the performance of the equipment that's been selected for the house, and determine if they are meeting these qualifications before you actually select that equipment or decide that you're going to use a specific equipment. It's a good idea to go to that website, the NEEP cold climate heat pump list, and see if your heat pump is listed on that site and it meets these performance characteristics. From a heat pump water heater perspective, it also has to be an Energy Star certified heat pump water heater. It has to be properly sized according to the next gen requirements, which you might see as mean that you have to have a larger tank capacity, like an 80-gallon tank instead of a normal 50-gallon tank. It needs to be installed within conditioned space, and then it has to have this connection criteria, meet the connection criteria. Basically, it means that it has to have a Wi-Fi connection, so that sometime in the future, the utility might come to you and say, we would like to turn off your water heater during peak demand so that we're not fighting with people that are trying to cool their houses or use a lot of electricity in a peak demand situation to heat your water heater. So it's really a demand side management potential in the future that is governing that requirement for Wi-Fi connection there. And then, like the NEEP website, there's another website called the Northeast Energy Efficiency Alliance that has created a heat pump water heater list. And you can go on there and input the model number or look up the model number to see if your water heater qualifies for the requirements for the Marshall Fire rebates there. There are other requirements or other existing home requirements for performance that are out there as well. So if you're in an existing home and you want to get rebates for your existing home upgrades for heat pumps or heat pump water heaters, you can go and you can find those performance requirements as well. And again, it's best to look at your specific utility criteria in order to get those qualifications there. So we're going to move now to have Sean and present Sean Lamons with, we'll look at cold climate heat pumps versus non-cold climate heat pumps.
Perfect. Thanks a lot for that rundown, Robbie. Appreciate the opportunity to chat about the differences here on the equipment. I'm going to start with this slide, and it's enough. Maybe some of you have seen this version of the slide before, but it's basically identifying that in the US, heat pumps have now outsold for several years in a row. They've outsold furnaces in terms of quantity and volume, as tracked by AHRI, American Heating and Refrigeration Institute. And they're in charge of tracking these things. So I just wanted to point out for folks that heat pumps are they're gaining ground in the industry. They're gaining popularity. Yes, there's challenges with understanding and application of heat pumps, but pretty soon, so the one thing that heat pumps can do that furnaces can't is cool. And so of the all the millions of systems that were represented on this chart, heat pumps will soon overtake air conditioners as well, because they can also cool, as Robbie's been talking about. They cool in the summer and they heat in the winter. Go ahead, Robbie. So taking sort of a basic view of heat load calculations and how we go about this, we look at the building, the home, or the envelope. Some people say, you might hear that term multiple times tonight, but they take a block load calculation. That's how much heating and cooling has to be done for the house overall throughout the year. Sorry, let me rephrase that. How much heating and cooling has to be done within that envelope, within that building, for 1 hour worth of work in the cold days or the hot days. And that's, basically more than 99, it will meet the needs of the set point more than 99% of the time. And that's based on weather data, et cetera. And we can dig in deep on these if you want to, but I have these three images up here to say, it's not just about the block load. It's not just about the volume of the home overall. It is also about the zones that you have in the home. And this image shows sort of, living room, kitchen, and bedroom suites, but also maybe about the rooms themselves. And that would be the sort of the basic room by room calculation. And that might have to do with how much heating and cooling, how much airflow has to come into those rooms on a regular basis to satisfy the comfort for those rooms. And so these are different ways to think about how an HVAC professional will size equipment and size the distribution around the home to maintain comfort. Go ahead, Robbie. And so looking at the home overall, it is not just it's not just the walls and the windows and the ceiling and the floor, as indicated by what's in the plan set, right? The builder's construction plans, but it's the insulation details, it's the layers of materials that add up to an overall R value. It's the type of windows, not just a sort of thermal ability, but its ability to let in or keep out sun. It's also the air tightness of the envelope or the building and how it's put together. So there's thousands of little leak points around that envelope. And so newer homes have requirements around air tightness that are checked with the blower door test during construction. And that information, all of this information and more, feeds into the heating load calculation for the winter, as well as the cooling load information for the summer. And all of that goes into the system selection. Go ahead, Rob. All right, so this math that we're talking about here in those calculations, it's comes from a group called ACA, Air Conditioning Contractors Association. of America, sorry, Air Conditioning Contractors of America, ACA. They write these books that basically set the standards to do all the math. And the Manual J is the load calculation. The Manual S on that left side is the sizing of equipment, and the Manual D on the right-hand side, it applies if you have ductwork. Not all homes have ductwork. There are other manuals as well in terms of proper system design, but this is, you might have heard this term in the past, either from your builder or your first grader, or maybe from the code official or someone along the way. But this is just a little representation of some of the documents that are generated on behalf of the system sizing and for the home that you're building. And it's important that those numbers be correct in what R values and what air tightness and what window performance specs and other details. And do they have to be perfect? No, they don't have to be perfect. We sort of operate in this plus or minus 10% business, but it is important that they are reasonably correct and reasonably close to the home that you're building to set the pace for the system selection. Go ahead, Robbie. And on one back, please. There you go. And so on those system selection, this is an important piece. We're taking the math that was done to determine how much work or how much heating or cooling needs to be done for the home in those worst days. And then manufacturers have tools that are available to HVAC professionals to help determine what those heat pumps or what those HVAC systems are capable of doing at their design conditions. So we think about what are the temperatures, what is the elevation, what are the systems being connected, and what are they capable of doing where your home is located at. And elevation and orientation and those kinds of things will play into the loads, and then elevation and connection and system build out will be represented on these software tools to help the HVAC professional select the right equipment to meet the need for the home on those worst days. Go ahead, Robbie. And so once you have the loads are done, and now we've matched up with the equipment, you're gonna there are various lists that an HVAC professional will look at to find the right piece of equipment. One of those lists is the NEEP cold climate air source heat pump selection list, and this is really useful for helping identify systems that will operate in colder temperatures. And maybe an HVAC professional looks under the brand or looks under the sort of configuration of the equipment. But really, I'm highlighting in this image that is a snapshot from the NEEP list where the AHRI or the model number of the equipment can go in. It's a very flexible search tool. And when you type in the model numbers or portions thereof, or the HRI number, it's going to pop up whatever equipment meets that search criteria, of course. Now, what I also want to point out, if you look along the bottom, there's 3 gray boxes. Above the middle gray box, it says 128,507 heat pumps. That's a lot of combinations. And so now we start to see the deep, dark equipment selection world and just how tricky it can be to find the right piece of equipment. Just one letter or one number difference can mean the difference between sort of success and challenge in that home and how things work out. So it's important that the HVAC professionals are using the tools that are available to them to find and apply the right pieces of equipment. And you as a homeowner or maybe other building professionals can use the AHRI numbers that are potentially available on the documents that you have, or the model numbers, etc. You can go onto the website and see and type in those numbers, and you should be able to find your piece of equipment in this list. And if you don't, that's a pretty big red flag to identify or start asking more questions. Go ahead, Robbie. Now, looking at these 2 charts, I tried to boil it down to sort of simple comparisons, right? When you're looking at both of these charts are off of the NEEP cold climate heat pump list, and it shows the capabilities of the systems as rated. And so the blue lines that are vertical and they stand sort of up top to bottom, and it's a bit of a pile, right? That's shows the weather data for our area. It shows that there's a lot of heating hours, if you will, a lot of hours out of the year that are between, say, 20 degrees and 40 degrees, or even 50 degrees outdoor temperature, right? So there's most of the hours in the year are within those time frames. And as they trail off on the tail ends, left side down towards 0, right hand side up towards 60 degrees. Those are diminishing hours within the year that the system has to really do its job. And then the line that starts on the right hand side and slopes down to the left towards it's the red line as opposed to the orange line. That red line is what the system is capable of doing in the weather conditions as it gets colder. And the line that is bottom right sloping up to top left, that orange line, and on the lower one, it's a green line. That shows the heat load of the house. And that it goes back to the manual J. And so these hypothetical examples right here are basically showing that intersection point. Right as those two lines intersect, that becomes the point where you might need additional heat for this heat pump. And so these two different heat pumps, one of them, as written down on the left side, one of them having 70% capacity at 5 degrees. That's one of the basic criteria of a cold climate heat pump, according to NEEP. So the top example is going to need backup heat added above that capacity line. So that red triangle that's between those two intersecting lines, that red triangle is backup heat. And it can be electric resistance, which tends to be higher cost to run because it's effective, but it's 100% efficient when it's inside the house, but it's not heat pump efficient. So you're going to be paying more to heat your house with electric resistance within that red triangle. And you can also have a gas furnace backup. So you're going to be and so most existing homes have gas already on site, and some of them are looking at adding it in for the rebuilds. And so you're going to have a lower cost to run the natural gas furnace within that red triangle. And then another option is looking at a heat pump that does 100% of heating at 5 degrees. It's a different category, if you will, of heat pump, cold climate heat pump. And I know it's confusing, and we're still trying to figure out how to just differentiate those within the industry in terms of naming convention. But just know that there is equipment that is able to do 100% capacity at 5 degrees. And that red triangle that we talked about, that extra backup heat, it's no longer really backup heat. It really becomes supplemental heat. It's a little bit of extra added heat and a little bit of time, far fewer hours out of the year. And so when you think about supplemental heat, think added on top of. When you think about backup, it really is about instead of. So there's a changeover temperature, probably right where those lines intersect. And that's how many hours in the year that backup heat might be applied in your home, as opposed to a little bit of supplemental heat for the heat pump that operates at 100% capacity at 5 degrees. Long explanation. Apologies for any confusion on that. Please ask Zach in the Q&A if there's for any clarity on that. Go ahead, Zach. Or sorry, go ahead, Robbie. Yeah. So a couple examples. We've got some data. A friend of ours that works at the Colorado Energy Office has gathered some data on a few homes, 4 homes. The first one that you're seeing here is house 1, and a few bits of criteria and description there. But it's an existing home built in 1991 with some improvements done, air sealing and such. They've got solar on the roof and 10 kW of solar, and the gas furnace turns on at 15 degrees. according to that chart that we saw before, right? So the gas furnace turns on at 15 degrees and heats the house below 15 degrees. The equipment ratings are shown and the kilowatt hours, November and December kilowatt hours. Apologize, they're not more recent, but we had sort of gaps in the data, so we wanted to just show comparisons here. So this is showing how much energy was used in the house in November and December for an existing house of these conditions. Go ahead, Robbie. The next house, house 2, is, yeah, let's stick on house 2 for a moment there, Robbie. So the next house, this is a new home in the Marshall Fire area, 4,000 square feet as well, and built to the IECC 2021. It's got an electric fireplace, 10 kW solar on it with electric backup. And so instead of a gas furnace, this one has an electric backup, but there's a key piece here. That electric backup is not set to turn on at any specific temperature. The system is smart enough to see when does it need that electric backup to kick in. And so there's intelligence on board the system that helps manage that cost a bit. So, so actually more efficient equipment by about, call it a little bit more than 10%. And then actually about 10%. And then also 10 kW solar, but far less usage of the backup. And so actually, when we convert the heat and the energy usage over to kW, just for apples to apples comparison, it's basically the same as the existing home that has seen improvements done to it. Go ahead, Robbie. So then houses 3 and 4, there were 2 houses that we averaged together just for ease of discussion and clarification. Those are both average out to about 4,000 or 3,900 square feet, also built to 2021 IECC with a gas fireplace and 14 kW of solar. The difference here is that the electric backup was set to 20 degrees and there are steam humidifiers in both of these homes. So we've got a couple, moving parts here that are significantly different. Fixed backup plus extra heat with the steam humidifier adding heat into the home, and even more solar. But look at that difference in that December, actually the November and December energy usage. So all the energy use added up to approaching, we'll call it 2 to 3 times as much energy in that. Actually, it's going to be more than that because I forgot. There's 40% more solar on the roof that is behind that 2,500 kilowatt hours. So substantially more energy needed to run those homes that are effectively the same home as house number 2. But we've got a higher changeover temperature. It's electric resistance backup, and we've got electric resistance creating the steam for the humidifier. And it's a lot we covered a lot there, but just wanted to show some comparisons. It's about the proper equipment selection, where it's going to do its best work, when does it turn on, and what type of fuel or efficiency does it have. Go ahead, Robbie. So some additional thoughts on this, like just to summarize this, that first line, non-NEEP qualified heat pumps. They're not bad heat pumps. They're great heat pumps. They're just not the best fit for our climate in Colorado. They might be better for more southern, a little bit warmer, more mild temperatures, or areas that get really hot, but just not all that cold. That's a heat pump plus probably a gas furnace. And those heat pumps are going to see a changeover or balance point, or that intersection of load and capacity at about 32 degrees or something like that. It's not always that number. It could be 40, it could be 20, but it's around that freezing temperature. The next category is the NEEP 70% at 5 cold climate heat pumps. And you're going to see that heat pump matched either with the gas backup or electric resistance. But that electric resistance, as we just saw in the previous slides, it tends to add a lot more operating cost. Maybe it's a great fit for the house. Maybe that's the choice that is the right equipment choice for the home for whatever reason. But the recommendations would be look at a gas backup for lower cost of operation, long term, and a changeover temperature, around 5 degrees positive. So greater than 5 degrees. And it's entirely based on the capabilities of that heat pump and where that intersection of load and capacity are. Now, the third category is that 100% NEEP qualified heat pump, 100% at 5 degrees. And it's a cold climate heat pump plus the supplemental heat. And typically, if it's new construction, doing supplemental heat in an electric resistance can be very effective. And it's only going to be applied if it's needed, and you can see those changeover temperatures at being less than 5 degrees. So these are generalizations through kind of 3 different categories to think about for different types of equipment. Different types of heat pumps and what their backup heats are. A couple other points, and then I'll be finished up. Consider average billing after 1 year of operation. I saw one question in the Q&A here that was about sort of managing costs over the year. The average billing can be a great way to do that with the utility company. Basically, they're going to see all the different usage of the energy around the year, but then you ask them to average that for the following year. They're going to look at how much you used last year. They're going to average it out, and they're going to bill you that effectively month over month. So you smooth out your cost of utility billing. And if you use more that year, that average is going to go up. If you end up using less that next year, your average is going to go down. So it's a great way to flatten out the cost of operation from January bills to September bills to July bills, etc. And then also thinking about that capacity or capacity balance point or economic balance point of the equipment per manufacturer guidelines. Different equipment, it operates differently, has different capabilities. So talk to your HVAC professional about that balance point. And if you have the ability to let that be automatically selected by the system, so it can often be a great benefit so that you're not turning on the extra heat when you don't need it. I think that's it for me, Robbie.
Great, thank you. Now we're moving to living with heat pumps with Paul and Stuart.
Hi, my name is Paul Bousquet, and I'm with Go Electric Colorado. My colleague Stuart Cummins, I call myself a tech electrification geek in training. Stuart is the chief decarbonization and technical person for Go Electric Colorado. He studied aeronautical engineering, was a Navy test pilot, and loves tinkering with homes, autos, you name it. So what we are here to do is help anyone translate any of this deep, technology that you've been, listening to this evening into functional, how does this work for my house? What do we need to know if we're bringing in a new piece of technology? It's not a gas furnace, not a gas water heater, and some of the really nitty gritty of selection. So our organization, Go Electric Colorado, is a group of folks who've gotten together. We have been decarbonizing and electrifying our homes. We have several years of experience with heat pumps, heat pump water heaters, induction cooking and drying and so forth. So we have collected all that information. We've done over 100 home consultations where we've gone into other people's homes and helped them figure out how to retrofit their homes or select the right equipment and contractors for their goals for their home. So what we can do for you is, if there are ever any questions in your mind, how is this working? Contact us. We are here to help you. We're free. So you can go to our website and book an appointment. We'll talk you through any of the issues that come up pre, during, or post installation of your electric equipment. I'm just going to kind of kick it off with a few very high level thoughts about what goes into a heat pump from the user's point of view. So, very few of us got our first computer and just went to the store, bought it, and knew what to do with it or how to use it. But that's what's kind of happening with home ownership in this new world of electrification, right? You're given a bunch of new equipment. It's a little bit different. If you try and apply the same techniques as you did to, say, a typewriter to a computer, you're going to be underutilizing that piece of equipment. And there's a whole world of ways these technologies differ from what we had. So a couple of reasons why we think going electric is a good idea. One is it's way cleaner form of heat in our home. It's climate and planet friendly, so it's giving our grandkids and our kids a better future. And it can, when sized and operated properly, reduce our energy load overall, because this equipment is actually more efficient. So I'm going to turn it over to Stuart to talk a little bit about what you can expect from your heat pump system and some tips on, for new users on how to use it. Take
Thanks
it
a
away.
lot, Paul. And so, so you had the master's level presentation from Sean. There's going to be a test, by the way, so you can get your rebates. But we're gonna give you the grade school, the high school version. And like Paul said, this is a new machine. I think one thing that's not emphasized enough in these conversations is that these are really revolutionary devices. These are things we just didn't have a few decades ago. And I mean the heat pump that you're going to put in your house, and also the heat pump hot water heater that Paul and I will talk about in just a couple of minutes. So when Paul talks about tips, this is kind of where Go Electric Colorado comes in. We just come in. We're just normal people like you, neighbors. We have a lot of experience. I'll point out somebody else who's here. Eric Stonebreaker is also here. He, like myself, has an all-electric house. We have no gas connections, and we've been doing that for years. And we have a lot of data under our belt. So some of the tips we're going to give you is that heat pump's a different animal, unlike your old furnace that just blasts on, gives you a huge blast of heat, then turns off. The heat pump essentially runs continuously, runs 24/7. And whereas a lot of you might be used to turning the heat down or turning it off at night. I grew up in Boston. We just turned the oil furnace off at night, woke up in the morning to a freezing house, and then the oil furnace just roared back to life and heated the house up in a few minutes. You do not do that with a heat pump. The average setback for these heat pumps is about 3 to 4 degrees. To wit, my house has all mini splits, and built into each of those mini splits is basically a 4-degree setback maximum. So they sense when you're out of the room for 30 minutes, and they'll go back at most 4 degrees. And when you walk back in the room, they bring it back up. So it's like the tortoise and the hare. I have this in Paul's notes. It's a really good analogy. They're just slow and steady. And because they're infinitely variable, as Sean covered, they know they can modulate themselves all the way back to a very low power consumption level. And you can watch that on a power monitor if you have one. Let's see, you're going to have superior air mixing, and as a result, you're going to have superior comfort because they're running all the time. Unlike your gas furnace, they're going to mix the air in your house a lot better. If you have mini splits, you'll have precision temperature control and air mixing in each room. And then switch over temp. You've heard a lot about that from Sean. That's something you're going to want to watch. And that's something we can help you with when you move into your new homes to make sure it's set properly. Great example is about 1.5 years ago, one of our earliest consults, the gentleman had, I think, the same system that Eric Stonebreaker here had. It's a Bosch. It's a pretty good cold climate heat pump. And the set point was really, really high. And this homeowner was actually able to go in and manipulate it himself and turn it down. So that's another thing you want to check for. Paul, back to you. Throw out a few more things on using heat pumps.
I did want to mention, Stuart mentioned something called mini splits. So all of these systems have an outdoor component, which is the compressor condenser, and then it sends this refrigerant fluid into your home, either to an air handler, if you've got a ducted system, very much similar to generating a constant flow of air over a source of warmth to bring the warmer air throughout your house, through the ducts that are built into your home. They're just like your current gas furnace perhaps. And then mini splits are usually either in the ceiling or on the wall, and they are very fine tunable to the environment they're in. So if they're in a room, they can adjust the temperature in that room based not only on what you set it at, but also any activity in the room. So if they detect that you're in your home office for a few hours, it's going to kick up to what you ask it to for the room comfort level you've set. So there's ducted, ductless, and then there's something called a combination, which is, like you might have guessed, a combination of your house might not be able to accommodate ducts throughout for whatever structural reason. So we put a mini split in that room where maybe you formerly had another form of heating or no heating at all. So that's something I wanted to, capture.
And
Set
Paul, I'm just
point.
gonna, oh, great, you're going to answer set points. Thank you for
Yeah,
answering that.
I wanted
Just
to
a
talk
quick
little
time
bit
check. We've got about 7 minutes left. For
Okay,
presentation.
so, set points are what Sean Lamons was talking about is depending on the equipment you have, your contractor should set a set point for when that system asks for backup or supplemental heat from a source that is connected to the controlling device. Formerly, you might have called that a thermostat. Now we tend to call it a controller, extremely sophisticated device that can monitor a number of different data points and select when to heat and what source of heat to be most efficient. Let's see, now we're going on to Stuart, I'm going to let you take it from here.
Sure. I got Paul. So just a couple other things to consider. Placement of the compressor, that big box that sits outside the house. You're in Colorado, different parts of your house, sides of your house mean different climate zones. So talk to us about where you can put that in your house. It can make a big difference. Other things are you want to protect it from snow. Most standard installs, that thing's going to be put up on a stand about 18 to 20 inches high. And since we're running out of time, I think we've talked a lot about heat pumps. Let's go to the heat pump water heater. Robbie, can you advance the slide? Great. Thanks. This is another revolutionary device. I get really excited about this. And reason why, if you look over, there's a chart there with some electrical data. Look at the February usage number, 26.7 kilowatt hours. I'm going to tell you what that means. So that's on February 23rd. So we're basically almost 3/4 of the way through the month. And look at that. That means I've used 26.7. That's less than 1 therm of gas equivalent. And I've heated, that's, for 3 weeks worth of hot water to women in the house. I use plenty of it. And that's less than 1/3. If we were looking at a gas water heater kilowatt hour equivalent, we'd be looking at about 15 therms up there. Again, 26.7, 1 therm is 29.3 kilowatt hours. So again, these are revolutionary devices. What is it? Take a look on the left. It's just a standard electric water tank. Bolted to the top of it, that big red thing is a compact heat pump, and heats the water 5 to 7 times more efficiently than most efficient gas furnace. Hopefully you get one of those in your house, and we can tell you how to use that too.
Great.
Well,
thank you so much. That was great, guys. I just want to finish up here with some resources. Hopefully everybody's familiar with the rebuildingbetter.org website. It's the website that's been kind of our guide throughout, that has all the information about rebates and how to pick your team and do all those things. So definitely go to that website. EnergySmartYes.com is another informative website that's put together through Boulder County and their Energy Smart program. You can go there and see a lot of the rebate incentives for existing homes. And there's, again, tons of information there. Stuart and Paul are with Go Electric Colorado. They have a website as well that gives lots of great information, and you can schedule and find out how you can get somebody to come to your house if you have questions about your house. And then the last resource we wanted to throw out there is Love Electric's website that offers statewide rebate resources, education, and also new and existing home information there as well. We're going to move on into the Q&A portion. So again, type your questions into the Q&A pane. We've been answering some of them as they've come along. If they're specific to your house and not kind of general for everybody. But if you have questions that aren't answered tonight, don't hesitate to email your questions to me or give me a call directly. And if you have questions specific for Sean, you can email me as well, and I can get that to Sean as well. And then there's the information for Go Electric Colorado, or if you have general questions for Energy Smart, you can go there as well. So let's move into Q&A, Zach.
Yeah, so a lot of really good questions. I'm going to highlight some that have been answered and some that haven't. And again, we'll keep typing your questions in the chat. We will get them all answered. We will also share this presentation and the recording of this webinar at the end of the webinar. Let's go with David asked, the sound home envelope. A sound home envelope sounds like a function of the home, meaning you could have a leaky home. Does that suggest that some homes won't work well with a heat pump? There's a couple answers already in there, but I just wanted to chime in on that one and say my last home was built in 1902. That was originally a very, very, very leaky home with no insulation. The home put insulation into it and did some air sealing and had a very successful experience with a heat pump in that home. So it is, as Sean pointed out, a relative, a leaky home is a relative term. There's a way to measure it with a blower door test. And obviously less leaky and more insulated, more airtight is better as long as it's properly ventilated. But that, if you have a leaky home, that does not mean you can't get a heat pump. It's just something to explore and consider, what insulation and air sealing you could have there. There's a really good question that I want to make sure we answer. Sean, you mentioned that in the design calculations, it's designed to cover greater than 99% of the heating and cooling. Does that mean that a heat pump won't heat or cool approximately 1% of the time, or roughly 2 to 3 days a year, or 3 to 4 days a year?
Was that back to me?
Yeah, back to you. Yeah, since you that was your comment. Yep.
Yeah, the short version is this is based on weather data, and it's not it's about averages over time. It's about measurements over time, right? And so just because a piece of equipment is designed to just the gnat's hair, so to speak, right on the balance of 99%, doesn't mean that it won't operate very well at that design condition or even colder. I have data monitoring on systems that were designed for the heat pump was put in to meet the design temperature of the house, and the heat pumps 100% capacity of 5 type of heat pumps were able to push way past that design condition. I'm not saying every heat pump will do that, and not every house will have that experience, but it is absolutely possible. It's also important to think about what kind of backup, what kind of sort of supplement are you comfortable with? Do you need something that's automatic and will kick in without even being there or thinking about it? Or are you okay with having a space heater that you plug in, a couple days, 2, 3, 4 days a year with a little extra heat added in? It's really about your own personal comfort, and but really using the design guidelines as a backstop to all the parameters, expectations, professional practices, etc., that go with it.
Thanks, Sean. I'm going to combine a couple of related questions around the performance of heat pumps and the need for backup. JD commented, I've read that some contractors are really pushing no, wrong question. All right. This is the question I wanted to read. I've received multiple quotes to replace my HVAC, furnace, and AC with a cold climate heat pump. The contractors keep pushing a dual fuel system for when temps drop towards 0. Would you recommend this setup, or do you believe a standalone cold climate heat pump should suffice for our Colorado weather? And then as you're answering that question, there was another question from Tanya on, are there any heat pumps that don't need supplemental or backup heat? And we had a couple of I think I'm excited to answer this question live because there's a couple of opinions about this. So first, whoever wants to take it, would you recommend a dual fuel, or do you believe cold climate heat pumps should suffice for Colorado weather?
I'll jump in, I guess, there, because I typed an answer already. Yeah, I think it really depends. And if you're talking about an existing home, it depends largely on the condition of the existing home, what the building thermal envelope is like, how airtight it is, and what's the condition of the duct system in that existing home. It can make a lot of sense to use a gas furnace backup, but you also want to understand the switchover temp and that it's backup, not supplemental, as Sean was talking about there. I have a house that was originally built in 1910 with a newer addition that was built in the 2000s. And I decided to install a heat pump with a gas furnace backup, largely because the duct system, I don't think, and the building thermal envelope would not work well with a heat pump alone and using electricity as the backup. I think it would just be too expensive. The other thing there is that you can get furnaces that have complete modulation or fan speed, which enables you to run it low and slow continuously at very limited cost there. So a lot of it depends on the shape that your existing home is in. So an energy audit might be a good thing to consider about, and consider doing some upgrades to the building before you consider adding a heat pump.
I'll chime in a bit too, real quick. Existing homes are a wide range of realities, and I think dual fuel is going to be a very viable transition for us as we move through this new technology. But just because one company is focused on dual fuel doesn't mean that it is the only way to go. It's about the load calculations, do the math. It's about the capabilities of the system, check your math, and look at the capabilities and what your comfort level is. I know many homes that have 100% capable heat pumps without any backup that are doing just fine, not only in the Front Range, but up in the mountains as well. And there's back to the Zach's example of an old brick home in Denver. A friend of mine has a 1922 home, double brick, and he oversized his heat pump just because, based on the load. But the system is performing comfortably, and he wished he went one size smaller, and he doesn't have backup system on that heat pump.
So yeah, and let's stick with that question of do heat pumps always need a backup system? Robbie gave an answer which I like, coming from Boulder County government. We would advise that you strongly consider it, but I think Sean has just shared that it certainly can be done without a backup system, and I invite the Go Electric Colorado folks to comment on this question as well.
I would chime in and say we have seen a number of 4,000 square foot houses that don't need supplemental or backup heat. And no, it's not every manufacturer that can do this, but to say that you have to have supplemental backup, I disagree with that 100%. Stu and I don't have backup, and we're in 1950s ranches that aren't that well insulated.
I also, for the record, after saying that I can't say from a Boulder County standpoint that you shouldn't have backup, I will say that in my home, I don't have backup. But again, like I want to emphasize, not all heat pumps are cold climate heat pumps, and not all cold climate heat pumps are the same. Also, not all homes are the same. So one heat pump that works in a home of the same square footage as another home of the same square footage won't necessarily work. The load and the performance of the heat pump need to match. Great. Are they noisy? the heat pump, since it runs continuously, is it noisy?
Quick version,
Can-
they are like a refrigerator outside that it's the upside is they're quiet compared to air conditioners. The downside is they're loud compared to nothing in the winter. If you're used to walking down the sidewalk with no sound and just hearing the crunch of your feet in the snow, and then you hear a heat pump running in the background, you'll hear it. But it's a very, very quiet air conditioner sound. And if once you've heard it, you'd be like, oh, okay, it's not so bad.
And I'd say in my current home, I started this winter with a furnace, switched to a heat pump midway through the winter. The heat pump inside the home, the heat pump is quieter than the furnace was inside the home. The distribution, the fan, the blower motor is quieter. I don't hear the outdoor unit. Everything is quieter. I sleep better with a heat pump.
Yeah,
But
I'll
again,
second what
not
Zach
every
said.
heat pump is the same.
I'll second what Zach said. I think I'm the only person in Colorado with a Panasonic. You cannot hear the outside inverter. You can't hear it. In fact, I have a bush planted next to it. So when the bush is wiggling, I actually know it's running. In the indoor mini splits, it's just kind of a low whoosh there. Like people have said here, much quieter than the gas furnace it replaced.
I'll also add in too, part of the noise concern is vibrations. Depends on how that outdoor unit is mounted, how the line sets and sort of mechanical pieces are connected to the house. And if you do hear vibrations within the house, it's typically, it can typically be addressed with some sound dampening, either additional gaskets or extra slack in the line set or these kinds of things. Try not to get that piece of equipment mounted to a framed part of the wall. Mount it to the foundation, mount it to a high mass brick wall, or set it on the ground on a stand, etc. I suggest not mounting it to a framed wall.
So we had a couple of questions here about how to find a reliable contractor or manufacturer. We can't recommend any specific contractor or manufacturers on this call, but I will point you to, and I'm just putting in the chat right now, the EnergySmartYes.com website has a page for finding a contractor. And on that page, you will find a list of electrification focused contractors. That is not an exhaustive list, but that is the list of contractors that we know of that like pretty much or exclusively only do heat pumps. There are certainly other contractors out there who do a mix of furnaces and heat pumps and do them well. And we are working on coming up with criteria for a list that includes those as well. We don't have it ready yet. But I would encourage you, if you've got a contractor you like or a recommendation, I would encourage you to ask them what percentage of their heating system installs are heat pumps and what percentage are furnaces. If they're only doing 10 or 15% of their systems, the heating systems that they put in are heat pumps, I might look for some other quotes in addition to the quote from that contractor. If you find somebody who's doing 60, 70, 80% of their heating systems that they're putting in are heat pumps, I think they would likely have the level of experience that you're looking for. So don't assume that all HVAC contractors are all equally familiar with this technology. Some really are, and they want to see you install a heat pump. Some really aren't, and they're indifferent about it. And so you'll get differing advice from the contractors based on that. So do check out that link. And like I said, stay tuned. We're working on a broader list as well, but asking good questions of the contractor about their experience with heat pumps, their attitudes, feedback they've had from installs they've had, are all good questions to ask, and don't just assume that every contractor has equal experience.
Totally agree with all that. I would also add in a little analogy. When you think about driving in the mountains in the winter, you can either have a regular vehicle with very good snow tires, or you can have an all-wheel drive vehicle with adequate tires. And the Department of Transportation, looks at them as equal. So focus on what the contractor is comfortable and confident with. If you've got a Ford, go to a Ford mechanic. If you've got some other car, go to the mechanic that focuses on that and understands the ins and outs of that other vehicle.
We got a question on, there was a comment in the presentation that heat pumps run 24/7. They don't typically run really 24/7. They run a lot. They run a lot more than your furnace did. Under extreme cold, they may be running 24/7, and that is okay. But throughout the year, they're not actually running 24/7. I think there was a little bit of a hyperbole there in that comment that they, to explain that they run a lot. But the commenter asked, how reliable are heat pumps? What is the average time of a lifespan of a heat pump?
I'll take that one again, unless anybody else wants it. But I would say a typical heat pump is same lifespan as a typical air conditioner or furnace in terms of engineering and manufacturing. Some are more durable and have longer lifespans than others. I know people that have 40-year-old furnaces, and I know people that have 40-year-old heat pumps. And yes, heat pumps have been around that long.
We had a couple of questions very specific questions on the refrigerants. Might throw this one to you, Sean. When will alternative refrigerants, e.g. R32, become available, and is it worth the wait for them? And then are all these cold climates using R290 refrigerant?
R30, the current refrigerant phase down is looking at R32 and R54B are the two heat pump residential heat pump refrigerants. Those are, if they're not available now, they will be available very soon. There is a federal requirement to make that change out basically this year, and then a 1-year sell through 2025 as well. So I would say now is the time. If you're not ready, then at least make a plan because those refrigerants are here now. And R290, aka propane, I might be mixing that up, but I think it's propane that you're going to see over in Europe, etc. We're not likely going to see that in the US anytime soon, although it's an exceptional natural refrigerant, does a great job when properly applied, but the National Fire Protection agencies they have different rules and regulations than what you might see in the EU or other places.
Great. Going to stick with you, Sean, for another question on the future of heat pumps. I've read that manufacturers are improving their air source heat pump performance in cold weather, and that these improvements should be coming out in the next few years. Does anyone have real information about that? Wondering if I should wait to get one of the new ones.
Yes, there's new equipment coming out from the major manufacturers. There's a program, a federal program called the Cold Climate Heat Pump Challenge that most of the major HVAC manufacturers are signing on to. And you're going to see some great products coming out in the next few years for sure. Some of those products, bench testing and field testing and real world, performance can be very different things. If you are definitely in a wait and see mode, I understand, but I would not continue to run a low performing / health impacting piece of equipment in your house if you're not sure. So if waiting makes sense for you and your situation, you'll see some cool stuff coming out soon in the next, call it 2 to 3 years, I would say. But if you are right now needing something, the equipment that's available today is excellent when properly designed and installed.
Great. Yeah, and I second that. I mean, I think the technology has arrived, and is perfectly adequate today. You know, like all things of like, do you wait to get a smartphone because they're going to get better in the future? No, you should probably get one now if you don't have one. And I think heat pumps fall into the same category. How often do heat pump water heaters need to be replaced?
I
All right.
can,
Okay, go ahead, Stu.
yeah, it's basically a standard water heater. It's an electric water tank with a heat pump sitting on top of it. Like any standard water tank, it depends on how much you cycle it. And I'm gonna just veer off and pull in another question here. I'm getting a lot of them about how to vent these things and that they affect the climate inside the house. No, they really don't. If you distribute the air properly, and if you can feed them, if you let them live inside the envelope of the house like they're supposed to, and just basically feed off of the warm air inside of the house, you'll minimize their cycling time. You minimize the cycling time in that heat pump. So, you know, who knows? You take care of it. 12, maybe 15 years in the outside. And I'm not supposed to say this, but you can change out the electrodes in them. Rheem, for example, I think I have one, Eric Stonebreaker has one. A lot of the guys on our team have the Rheem heat pump water heater. And there's actually a way to change out the sacrificial anode on it, buy you a couple of 3 more years of life on it. So standard water tank life, pretty much.
I'll add one more quick thing, which is, you know, heat pump water heaters, because they're drawing heat from the air, have a filter in them. So make sure you're cleaning your filter regularly. Same with your heat pump. So just keep an eye on those filters and keep them clean, because especially in construction, they get really clogged up.
We had a question earlier that I got answered, and then another one for the Inflation Reduction Act rebates that are coming through the Colorado Energy Office. The question is, when would those be available? Christine is with us from the Colorado Energy Office. Christine, I don't know if you want to pop on or if you want me to answer that.
Sure. Hi, everyone. The state, are you talking about the IRA rebates?
The IRA rebates, yep.
Yeah, so we are in the process of setting up that program, and it looks like the rebates will be announced in the fall. But as I mentioned in one of the questions, that I believe it's going to be 150% AMI. So there is a qualification for income on those.
And AMI is area median income. So
Yep.
the rebates
So-
would only be eligible. You'd only be eligible for the rebates if you're below 150% of area median income.
But I did put in the chat that there are some tax rebates that are currently available. So I'll put the FAQ in the chat, or well, I guess it's in the questions. Maybe we can put it in the chat as well. But yeah, so and feel free to connect with me if you've got questions on some of the state rebates and incentives coming up.
So we got a question with Xcel's new time of use billing. What do you suggest to reduce electrical costs? And for those who aren't familiar, I'll just explain that, and then we'll have someone jump in on this question. But so Xcel is rolling out this new billing system. It's called time of use, and they charge different rates at different times of the day. That allows them to reduce the peaker units, so the additional power plants they have to run, you know, when everybody comes home after work and, you know, start taking showers, turns on the dishwasher, you've got the TV running, all those things are happening all at once. So the time of use is designed to incentivize us to spread out our electrical use across the day. And so between the hours of 1 p.m. and 7 p.m., there's a higher charge, and then outside of those hours, there's a lower charge. So what can we do to reduce electrical costs with time of use? And if no one wants that one, I can take it. Okay.
Go for it.
I can answer one thing. I think the number one thing, obviously, is to modulate your electric car charging, EV charging. I think we all know that. Well, we take it for granted, but if you're new to the EV world, that's a level 2 charger that's pulling 7,200 watts, maybe 12,000 watts if you have a 50 amp charger. So right off the bat, don't charge your EV during peak times. Xcel and I think Energy Smart, they have standard recommendations. Don't run your dryer Your electric clothes dryer is a huge user of electricity. So simple things like that. We just told you not to set back or turn off your heat pump. So I personally wouldn't turn the heat pump off. It's probably at a very low level of power use anyway. Your heat pump water heater is only going to be pulling about 300 watts. It's up to you to turn that on or off. You can certainly put your water heater on a timer. Outside of that, there's not much else to turn off. And Zach, over to you on that. You got more ideas?
Yeah, dishwasher is another good one. A lot of them have delays. We prefer to run ours overnight. We set it on a 4-hour delay. It starts after we're asleep. We never hear it. And then, we wake up to dishes that are done and dry. So anything you can do to shift your load out of that window and your electric use out of that window is great. And I'm sure there are more resources online. Speaking of resources online, I just wanted to drop into the chat here. Energy Smart has, and this is also on the Rebuilding Better site, but I'm going to put the link from the Energy Smart site because I have it. Energy Smart put together guides for heat pump owners. So there's a ducted heat pump guide and a ductless heat pump guide. There's also an installation guide for professionals. So the installation guide for professionals covers some of the things that we have seen professionals who are new to installing heat pump make some mistakes on. And so, if you're working with a new build or an installer that you suspect may be new to working with heat pumps, that's a great guide to share as well. And those are in that link that I just put in the chat. And Christine Berg with the Colorado Energy Office asked me to put her information in the chat here. So I'm just going to put her email for everyone in case they have questions about the state rebate and incentives. We got a question on someone like to have their windows open. I mean, probably all of us like to have our windows open. Barbara asks, I'm used to fresh air through open windows during moderate months. Do you miss that with heat pumps?
I took a stab at that, and I'd say no. In moderate months or swing seasons, you can still open the window if you'd like to. Just opening the window, however, doesn't mean that you're actually ventilating the house. And so when the house is asking for actual cooling and or heating of the house, it's going to be more efficient to close the windows and let the system do its job to heat and cool the house. And then in our modern houses, that's really one of the reasons why we're asking for whole house controlled mechanical ventilation, that idea that we talked about briefly about building the house tight and ventilating it correctly for the occupants in the house.
Yeah, and there was a question that came up in the chat that I think got answered by text, but we didn't answer out loud about, on the build tight, ventilate right principle. Someone also mentioned their windows and they're used to opening their windows. Great solution, and many of us are accustomed to that in a relatively leaky house. But if you have a really well insulated, really airtight house, you really need proper mechanical ventilation that is not reliant on you remembering to go do it. And they have devices that have come up in the questions and comments a little bit called heat recovery ventilators and energy recovery ventilators. And these are heat exchangers that can be paired with your heat pump or really any heating system that take, we're in the winter time, so I'll give an example for winter, that take your warm air in your house as they're exhausting it out of the house and bringing in fresh air. There's a heat exchanger that crosses those two air streams. They're separated physically, but there's a heat exchanger in between. And so it passes the heat from your warm air in your house into this new fresh air coming into your house. So you get the benefit of heat air without basically having a window open because it's more efficient. So you get all the freshness of the air, but it gets preheated by your air going out of your house. And then in the summer, it does the reverse. So if it's really hot outside, you want that mechanical ventilation, but you have nice air conditioned air inside that's whatever temperature you want it to be at, it does the same thing, and it cools the air that's coming in from the outside.
If I could add really quickly
Yeah.
that we also have an ERV in our house, but and this is for Barbara, do we miss the fresh air? So no, in the colder months, we have the heat recovery ventilator, but in the summer, for most of the summer, we just open all our windows and maybe close it during the day and open it at night. We have a whole house fan. Whole house fans, swamp coolers, etc., are more efficient than using your heat pump for cooling. I know Stu does it differently. He uses his HVAC or heat pump all seasons with a HRV, and it gets that fresh air without the pollen, perhaps, or the wildfire smoke that we do have to shut things down for that.
We are coming up on time here. I appreciate that many of you have stuck with us and spent your Wednesday evening, an hour and a half with us. I hope that this has been useful to you. I think we have time for maybe one or two more questions. I'm going to take this one. I'm going to start off with this one because I also fall into this category. So someone asked, what if the homeowner prefers cooler temperatures for sleeping at night, i.e. 10 degrees cooler? Is that a challenge with heat pumps since they keep a more constant temperature? So I am also one of those homeowners. And our solution is we just close the register in our bedroom at night or a little bit before we go to bed, and then the room cools off. And then in the morning, we wake up, we reopen that register. We also have our heat pump set back to a 2 degree. So it drops in our house, we keep it at 67, and then it drops to 65 at night. But closing the register specific in our bedroom allows the whole house to maintain general temperature, but the one room to be cooler. I don't know if anyone else wants to take that one.
Yeah, so Zach, such a situation can be a great be really well addressed if they have a mini split in that space. So if they have a room where they're going to sleep in, maybe have a ductless unit in there, and then the ductless unit you can just shut that off. The rest of the house will stay conditioned, and you can chill the room that way. Maybe even close the door and crack the window open, because by definition, if that room is being conditioned by a mini split or a ductless piece of equipment, you can shut it off, isolate it from the rest of the house, and then have at it. Open your window at night, and then when you recover that temperature in the morning with that mini split head, you're only recovering just that volume of the room, as opposed to the entire house.
Yeah. We also have the ability now to zone ducted systems. It's usually limited to 2, maybe 3 zones, but you might be able to zone it well enough to affect the temperature in the wintertime.
Great, and that brings us to time. I see just 2 questions that we didn't either answer in the Q&A or answer live, and those are 2 that I think this crew might just not be the right crew to answer. One was, what is the most common thing to break on a heat pump? Maybe Sean knows that one with his experience working for a manufacturer, but I think probably the rest of us are just not the right people to answer that question because we don't have that experience. And then the other question was a technical question about settings with a humidifier and a heat pump. And I think that one might be a little bit beyond the knowledge area of this crew, but for both of those, I see Stu is answering that question, so maybe not. Stu's gonna be able to answer that one for you. But for both of those questions, great questions to ask your HVAC companies that you work with as well.
I will say the number one cause of warranty or no heats or warranty claims on heat pumps are refrigerant leaks. It's the installer not realizing or following the guidance on the manufacturer test pressures for the line sits. If they testing to 400 PSI when the system needs to be tested at 600 PSI, doesn't cut it.
Great, thanks. All right, so that leaves just one, and looks like Stu answered the other one. All right, so we got all your questions answered, and we are at time. Again, thanks everybody for being a part of this and taking the time and asking your questions. Again, we will send out the presentation and the resources and the links. And don't hesitate to reach out to Robbie, to reach out to Energy Smart, to reach out to Go Electric. folks with any additional questions you have. Have a great rest of your Wednesday evening.